All right, what do you think back there, Connor? You think it's linear? Connor?
Hello.
Hello?
Yes.
Yeah, we're
Yes.
talking to you. Do you think it's linear?
Indeed.
Okay, what's the constant change in x?
Yeah.
Of what?
An x of 4.
Okay, what's the change in y?
Of 3.
Okay. And then if there is a constant change, you need to tell me what it is. Okay, don't just say yes, linear. You got to tell me what it is. Now that goes up 3. Watch the negatives there. Up 3, 3 to 6. Up 3, 6 to 9, up 3. Now if you plot them, it'd be linear. So this is a linear function. Constant change. Man, it's a little touchy today. Constant change of plus 4 for x's, and then plus 3 for y. So constant change of plus 3 for y's. All right, so that's the key thing. You're really not used to that. It's something that's a little bit new. Now, sometimes if you want to just keep it like this, and I want to look at the x's, I can go -3 to 1 with the x's. And what's that a change of? -3 to -1 is a change of 2, plus 2. And then -1 to 1 is plus 2. And 1 to, whoa, hold on. 1 to 3 is plus 2. And 3 to 5 is plus 2. But what about the y's? 10 to 9, -1. 9 to 7, -2. 7 to 4 is -3. And 4 to 0 is -4. There is a pattern, but it doesn't matter. It has to be constant, not linear. Not linear, no constant change in the y values. Okay. Not linear, no constant change in the y values. Not linear. No constant change. For the y's. All right, is that the bottom of that first page?
Yeah.
All right, once you get done with that, flip it over. Now, if you want to put them in a table, absolutely fine. Because some people are just more comfortable doing that. Okay, another way to determine whether a function is, basically you should be able to look at the equation and tell me yes or no it's linear. Okay, and we'll have to go over why. Okay. A linear equation is any equation that can be written in this standard form. AX plus BY equals C. They're going to call this standard form. And what I mean by that, that would be like 3x plus 2y equals 8. Now, there can be negatives in there. It could be -7x plus 6y equals -2. X plus y equals 10. Those are all linear. There's just an x and just a y. And it kind of explains a little bit further here. Here's the key. X and y both have exponents of 1. No x squared, no y squared, nothing other than just a 1. X and y are not multiplied together. And x and y do not appear in denominators, exponents, or radicals. So even if it's rearranged, we can, if it's not in the same order, if we can rearrange it, we're going to do that. You're just looking for anything goofy. You can't have an x or y together. No powers, no y's or x's in the denominator. So if it doesn't look like it's normal, it's not going to be linear. Okay, so these are going to be the cases. Is that the same thing on your page right there? Okay, you got that same graph. Okay, so just what's linear and what's not. Okay, now take a look here. It says tell whether the equation is linear. If so, write it in standard form and give the values of A, B, and C. All right, well, hold on one second here. if I give you this equation, 5x minus 2y equals 8. That's in standard form because the x is first, the y is second, then your equal sign. A is 5, B is negative 2, C is 8. Joe, does that make sense? All right. So A, Joe, do you think that one is linear? Are there any exponents or anything goofy?
I just said yes. I don't even know.
You just said yes?
Yeah.
It is linear. Good guess. Now, Preston, is it in standard form?
Yes.
No. Here's standard form. The x piece comes first, the y piece is on the same side, and then there's your equals, and then the just constants by itself. Does that just equal the number? No. Grant. Do you agree it's not in standard form?
Number 1?
Yeah.
Yeah.
Okay, how can I make it in standard form? It is linear. This is for everybody. How can we make this? We got to rearrange it. So, Grant, any ideas?
Subtract 2y from each side.
You can subtract the 2y. We need to get the 2y to the other side. So do this. Minus 2y. Now, when you rewrite it, you'll just say x minus 2y equals 4. So this is linear. Now, you have to tell me what A, B, and C are. Christian, what do you think for A?
It's not X.
So.
What number is in front of the x, even though it's not written?
1.
So put a 1. A is 1.
When we ask you what A or B or C is, it's never going to be a variable.
B, okay, use the sign in front of it. B is negative 2. And then C is 4. Okay, for that. C is 4. So if it's linear, you just have an x, you just have a y. Then rearrange it if needed. It tends to be the hard part. And identify what A, B, and C are. All right, for B, Amanda, is that linear? What do you think?
Yeah.
Okay. No. And they throw, here's why. Go back up above at that chart. On that right-hand side, what's it say can't happen? Okay, the very top one.
X and Y are not multiplied.
X and Y cannot be multiplied. So this right here, X and Y are together. They're being multiplied right there. That lets me know it's not linear. All right, good. I need to see what you guys are seeing or not seeing. If it was X plus Y equals 4, that's linear. Okay, because that's not being multiplied. All right, what about C? This is your equation for C. Oh, this is like a trick question. Oh boy. C is Y equals 12. This is kind of unfair.
Agreed.
This is not fair. I apologize. Zach?
It's linear.
All right, it is linear. It is linear. Now, so for linear, you need to be able to write it as AX plus BY equals C. But you're going, well, there's no X. It's okay to be missing one of the letters. Can't be missing both of them, but you can be missing one of them. Because here's why. What I can do is I can take this and I can say, oh, that's 0x plus 1y equals 12. So that's okay. So my A is 0, my B is 1, and my C is 12. Okay, my A is 0, my B is 1, my C is 12. Okay, for that. All right, what about, that's a tough one. As long as you don't have that power, even if it just has one variable, you're okay. All right, y equals 2 to the x. Josh, what do you think?
So divide 2 by both sides?
First of all, is it linear? Do you
Yeah.
think it will be linear?
Yeah.
All right, I'm gonna disagree. Now take a look at those examples up above. Or see that, what would make it not linear? What's kind of like a red flag?
The exponent.
The exponent of an x. Okay, right there. We cannot have that, so that's not linear. All right. And now, Jordan, we got some catching up to do.
Okay.
So for E, do you think that's linear?
Yes.
Okay, it is linear. Okay, there's no goofy exponents. Is it in standard form?
No.
No. What do we need to do to get it there?
Subtract 5x.
Good. Subtract 5x. All right, now you got to watch how you write this, because if I write it as it is right now, it's y minus 5x equals negative 9. Make sure that you got that part down. Y minus 5x equals negative 9. That's still not in standard form, right, Jaylee? Is what's wrong with that? It's still at this point. What? Or you're not sure?
I don't know.
All right, that's good. Here's the deal. This is the way they've written the standard form. Which letter do they say needs to come first? Look at what I got in the box, Jaylee. Which letter does it say has to come? The what? A. What's with the A?
X.
The X has to come first. Okay, so this one I got the Y. So Colin, rearrange it for me.
Negative 5x plus y equals negative 9.
Good. The negative travels with the 5. And so it would be negative 5x plus y equals negative 9. And my A is negative 5. My B is 1. And my C is negative 9. You got exponents squared, or you got a variable in the exponent, not linear. Anything that looks goofy is typically not linear. Now, you can't have a fraction as a coefficient, which means like 1/2 x plus 6y equals 8. That's okay as long as the fraction is just a number. That's still linear. Yeah, that's still linear. All right, what do we got left there? The manicure. Okay. All right, at a salon, Sue can rent a station for $10 per day plus $3 per manicure. The amount she would pay each day is given by f of x equals 3x plus 10. Oops. That's how much she pays. Where x is the number of manicures. Graph this function and give its domain and range. All right, before we graph it, let's go down here and on the x-axis, go ahead and let's see. Let me look at what you got there. Okay, every 2 marks make it 1. Okay, so make that 1. We want to spread it out a little bit. 2, 3. And go at least to 5. 4, 5. Okay. All right, so for this one, can you give a negative number of manicures? No, you can't give negative 6 manicures. Okay. Basically, you could end up with 0. You could have a really, really bad day and give 0 manicures. But the x's we want to plug into our function will start with 0, 1, 2, 3, 4, and 5. All right, substitute those in. You see what your y value comes out to be. Okay, so make that chart. Use your calculator if you need to. Yeah.
No.
What's your study hall? 4?
Yeah. Yeah.
It's alright.
What do you got? Okay, good. Not yet, don't graph it yet. Rachel, what do you got when we plug in 0?
Oh, I got 10.
Okay, what'd you get for when you plugged in 1? Good, keep going.
16,
Okay,
19, 22, 25.
all right, good. Now, we want to graph it, but we cannot use like a scale of 1 for this. So what can our scale be? At least to get to 25. I want to get above that. Christian? 5. All right. If you're going to do, I'm going to let every 2 be 5 just to spread it out, but I think we can still fit everything in there. So that'd be 5, 10, 15, 20, 25. And then I'm going to go past that. Whoops, hold on. To 30. So I got 0, 10. I got 1, 13. So that would be 10, 12. So a little bit above there. 2, 16. 3, 19. 4, 22. And then 5, 25. These, whoa. Okay, they should form a straight line. All right, now what's the one question we haven't answered that it asked for? All right, I'll wait. You guys are still, I'll wait while you guys finish up. And do connect that. Because it did not ask us for a domain. We don't need to go into the negatives because we can't do a negative number of manicures. All right, that last sentence there says give its domain and give its range. So this is what makes sense. So for the domain, we cannot give a negative number of manicures. So we want to start at 0. You cannot give 1 point. Nobody, you're not going to do just one finger of somebody's hand. You're going to do nothing goofy. They're all whole numbers. So 0, 1, 2, 3, comma, dot, dot, dot. The dot, dot, dot means it continues in that same pattern. All right, Jordan. Let's see how if you can maintain your. See if you're still on fire here. Any idea about the range?
Be 5.
Be what?
The range be 5.
The range is not 5. The range are all your y values you get back. So what y values did I get back? Or in my chart?
13, 16, 19, 22, 25.
Yep, but I'm going to start with that 10. So your range is going to be 10, 13, 16, 19. And as long as I put those dot, 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 I don't need to list this. Now, theoretically, you can't give an infinite number of manicures, but we don't know how many in a day. So we'll just keep that dot, dot, dot for that one. All right, we good there? Now, make sure you follow these directions. 15 through 24. Do not graph any of those. The only one you graph is 51. All right, now we're going to collect your test back up. And what else are we going to do? Oh. Hey, 4-3, we got to
17, 9, 10.
I didn't like that.
I know.
13.
No.
I had to graph 1, 2, 3, 4. 5. It's not worth that one.
Yeah.
Are you getting these in class?
When I get on the test, it's like, no.
I mean, I keep fun.
Anybody.
Yes, thank you.
Skipped,
You got it.